Okay, is this visible to everyone? Yes, is it visible to everybody?
Yes,
Yes.
sir.
Okay, so this was a problem which was covered by Pathpur sir in the class. So this is a simple beam. So you can see over here there is a end A, and end A is basically a fixed support. Then we have a support at a distance of 4 meter. This is called as point B, and there is a another support. This is at point C. Okay, so this is basically a fixed support over here, and at B we can consider this as a roller support, and at C we can consider this as a roller support. As far as the moment of inertia is concerned, so moment of inertia, the span AB is having moment of inertia as I, and the span BC is having moment of inertia as 2I. So when you have solved this problem in the class, you have calculated everything in terms of E and I. Okay, even the rotational values that we have calculated, they are in terms of E and I. But when you go for the software, whether it is SAP or STAD or any other software, you will be getting values in terms of the digits. Okay, so you have to insert some value of E, you have to give some value of I, then and then only your values of rotation or maybe a displacement can be calculated. So based on that, you may find that there is a slight difference in the values which you have calculated manually and the values which you have calculated on the software. Okay, so there will be a slight changes. Okay, so don't worry about that. So what we will do today, we will try to analyze the same problem, the one which was solved in your class using the SAP value. Okay, so let me open SAP first. So I have already given you a demonstration of SAP in the earlier class. So this is a typical SAP interface. Okay, so let me create a new file. Before creating a new file, I need to see how much grid space is required. So if you remember in the orientation or the demo class, we know that the loading is there in X and Z direction, or the beam has to be defined in X and Z direction. So the vertical direction is basically Z direction and horizontal direction is your X direction. Okay, so in the horizontal direction, I'll be needing a grid which is having say this is 2 plus 2 plus 6, so that is 10 meters. Okay, so here this is my SAP, and if you see at the bottom there are units. So first of all you have to check the units. So what I'll do is I'll go for Newton and meter. So everything now will be taken as an input in terms of Newton as well as in meters. So now I'm going to create a new file over here. So as you know, we have to define a grid in X and Z direction. So in the X direction, I want to have grid spaces as 10 with a spacing of 1 meter, because in the problem itself, you will find this total distance is 10 meters and I want to have grid spaces as per my wish. So I can go for even 1 meter also. As far as Y direction is concerned, Y direction is not at all there because the loading is there in Z direction. Now in the Z direction, I just want only one grid. Okay, I don't want more than one grid, and its direction or its distance will be the 1 meter. So if you go and click on this, so you will find this is a 3D view over here, and this is the X and Y view. So what I'll do is this is an aerial view. So aerial view can be turned off. You can shut down this, and you can work on two different planes at the same time. So if required, but usually we take only one view. So now in this view you will find the loading is the beam has to be defined in X and Z direction. So here I will click X and Z, which is over here. This is a 2D view, so that now I can see the perpendicular picture of X and Z plane. Okay, so right now if you see at the top, this says SAP 2000 in bracket, there is a untitled. So this file is not saved. So let me save the file. Just a small hint in saving the file, because you see this is an old software, so do not save this particular file on a desktop. It is always advisable you go for a simple location. So I'm going for C, and in the C I'm going to create another folder, let us say SAP. Okay, see this is an older version, so you don't give the name of the folder which is having length greater than 8 characters. Okay, so the path should be as simple as possible. So in SAP I will say expp1. Okay, so experiment 1. So here, as soon as I save this, you will find this at the top, SAP 2000 dash. Now the file name is appearing, that is experiment number 1. So now let us start working on the problem. So we have to first of all draw all these sections. So I'll go for define. The very first thing is the material. So in your numerical which you have solved earlier, the value of E is not given. Okay, so I can take advantage of this. I can choose any of the material. So let us say I'll choose the material as concrete. So if you see the concrete and if you go for the modify or show material, so you'll find the modulus of elasticity of the concrete as 2.48 10 to the power 10. This is the default value. Okay, so there is no issue. We can take the same value. If you want, you can change this to say 2.5 if it is required. Okay, so in your numerical, if E value is given, you can insert that value over here. Right now I'm taking E as 2.5 10 to the power 10, and this will be newtons per meter square, because here you see at the bottom there is a Newton meter unit which is current working unit in the SAP. So this material definition is done. Then I'll go for define and say frame sections. So if you refer the problem, there are two sections. Okay, one is I and one is 2I. So what I'll do is I'll go for two sections, something like this. So let me draw over here. So this is one section, and here I'm going for this section. Okay, so this I am taking randomly because the value of I is not given or the cross section is not given. So the value of I can be calculated by a simple expression, that is BD cubed by 12. Okay, so for both the sections I am keeping the depth of the beam as same, but the width of the beam is, I am taking this as this is, let us say B, so this will be your 2B. So if this is B and if this is your 2B, the moment of inertia of this section will be BD cubed by 12, and here the moment of inertia will be 2 times BD cubed by 12. So naturally, if this is I, this will become 2I. So all you have to do is just multiply the value of B by 2 so that you can get the value of I and 2I. So randomly I am choosing some dimensions. So this is a concrete beam. So what I can do is I can assume the depth of this particular beam as, let us say, 500 millimeters, and the width as, let us say, 200 millimeters. So if this is 200 millimeters, the width of the beam will be now 400, because this is twice of the width of the beam as far as this beam is concerned. So I'll be defining two cross sections over here. So define, say, frame section. So here I'm going to modify the first frame section. So this is basically made up of concrete. So I'll select the concrete first. So depth of the beam is 0.5 meter, and the width of the beam I'm considering this as 0.2. And in place of FACT1, I'll write only I. Okay. So right now I have one section which is called as I, and its dimension is width is 200 and its depth is 500. Then I'm going to add one more section. So I'll say add, there is a rectangle. Okay, then I'll call this as 2I, and it is made up of concrete, and its depth will be again 0.5. But if you see the width will be now 0.4. Okay, so it will look like this. So if I say okay, so this is 2I and this is your I. So if you modify this, you will see it looks like a slender beam in the figure having 0.5 by 0.2 dimensions. And if you select this, so this is a kind of a thick beam which is having a width of 0.4 and depth as 0.5. Okay, so our material definition is done, our frame section is done. Then I have to go for the static load case. So remember, in the previous class we have seen the static load case. So if you don't delete this load case factor to 0, it will consider the self weight. So right now in your numerical, self weight is not considered. So I have to change this, and don't say okay directly, you have to change it first. So once you change this, you will find this value has been now changed to 0, and then you press OK. So the self weight factor has been removed now. So we have defined material, we have defined frame sections. Now we have to define the or rather the static load case is also done. Now we have to just draw the sections. So for drawing the section, I will have to refer the figure. So here you see I have a beam which is having 4 meter and another beam which is having length as 6 meters. So what I'll do, I'll say draw and say frame element. So from here, so this is 1, 2, 3 and 4. So one beam is drawn, then this is 1, 2, 3, 4, 5 and 6. So I have drawn 2 beams. Okay, so I have successfully drawn these 2 beams. So now I need to allot the member properties. So a span AB is having I and span BC is having 2I. So I'll select, first of all, I'll select this arrow. I'll select this arrow, I'll select this beam, and then I'll say assign frame sections. So I have to assign, I think there is some issue because FACT1 is still okay. This should be concrete, this should be 0.2, isn't it? And then I have to add rectangle. I don't know why this is happening. This should not happen. 0.5 and this is 0.4. Okay, so this should do now. Okay, define frame sections. Yes, both the sections are now there. So this is FACT1 is I, FACT2 is now 2I. Okay, let me check. Yeah, both are okay. So now you see I have defined this as FACT1. So this is I. This is also by default it is defined as FACT1. So I need to change this. So I'll say assign frame sections. So I'll select this. So FACT2. So now we see section A to B is defined as FACT1 and B to C is defined as a section as F section, frame section 2. Okay, then in the numerical you have to define the supports over here. Okay, let me save the file. So I'll select this particular end and then I'm going to apply the support over here. So this is a support, so this is a fixed support. So I'll select this fixed support and I'll say okay. So the fixed support is there. Then at joint B and at joint C there are roller supports. So I'll select this joint. Okay, I'll also select this joint. Okay, and then I'll go for a roller support. So roller support is defined by this one. So I'll say okay. So the support definition is done. So let me save the file. Okay, then we have a concentrated load which is acting at a distance of 2 meter from end A on the frame section A and B, and the loading is in the ground or the in the direction of the gravity, and its magnitude is 10 kilonewtons. Okay, right now our units are in newtons. Okay, so don't forget that. So let me select this frame section. As soon as I select this frame section, this icon is getting activated. So here I can provide different types of loads. So the first thing is the concentrated load. So the concentrated load, it is acting at a distance of 2 meter. So distance is 2 meters and its value is, sorry, this has to be absolute value. So once I go for absolute value, so this is 2 meters and its value is 10, and now it is in the direction of the gravity. So here you can see this is, there is a direction over here. So if you want, you can change the direction as per your choice. So you can go for global Z direction, but if you choose global Z direction, so global Z direction is the vertical direction. So in that case you may have to go for a -10 over here. But if it is like that, so let me do this. So this is global Z direction. So global Z is vertical. So the value should be in the negative side. Okay, so if I select this, so it is going to apply a load of 10 kilonewton, which is in the negative direction of the global Z, and it will be acting at a distance of 2 meter from this end. So once I press OK, so you will find there is a 10 kilonewton load which is acting exactly at the center of the beam. So let me save this file. Then another load is the uniformly distributed load which is acting over a span of B and C. Okay, so I'll select this. Okay, so as soon as I select this, this icon is activated. So now I'm going for, first of all, let me delete the older load. So you have to delete this, otherwise the same load will be transferred on that beam also. And then there is a bottom, in the bottom there is a uniformly distributed load. So if you refer this, so uniform distributed load is 10 kilonewton per meter. Okay, so if this is 10 kilonewton per meter, so I will go for 10, but here I have to go for kilonewton. So 1, 2, 3. Remember, I have not given a load in kilonewtons over here while defining the concentrated load. So I have to replace this. Okay. Anyway, so let me finish that load definition over here. So once I say okay, you will find it is getting acted in the vertical this direction. So here also I have made some mistake. So this has to be there in the negative direction. So let me change this first. I'll select this. I'll select this. Then in place of going for global Z direction, I'll keep the same thing as global Z direction, but the direction I'll keep in the negative direction, and I'm going to replace this. Okay. So the earlier load will be replaced with the newer load. So you can see now it is corrected. Okay. Similarly over here, I have given a load wrongly. So let me delete this. Okay. So this has to be absolute distance. In the global Z direction, the distance should be 2, and the magnitude of load should be minus 10 into 10 raised to power 3. And I have to replace this, the old load. Old load has to be replaced. So this has to be deleted and the fresh load will be acting. So now you see this is correctly added over here. Okay. So as far as this problem is concerned, my material definition is done, section properties are done, frame section is drawn correctly, then the supports are also done, and the loading is also done. So let me save this once again, and then I have to analyze this. So before analyzing this, you have to choose a type of structure. So this is a plane structure. So where you have displacement in U direction possible, displacement in Z direction possible, at the same time the rotation is also possible. So let me save this. Okay. So this is done, and then I'll go for analyze and I'll simply say run. So you can see the analysis is completed. So there are no errors in this analysis. So now if I set OK, so it will go into the post-processing mode. And this is a typical deformed shape of the beam under the application of the given loading. So now uh, I think you have already calculated the rotation value. Can someone tell me how much are the rotation values, please? Anybody? Rotation values, anybody? I think it is this one. Is it right?
Yes, sir. Minus 20.132. Yes, sir.
Okay. So can someone do the calculations, because the value of E is known to us and value of I is also now known to us. Can somebody do the calculations, please? So E value, I think we have taken 2.5 into 10 raised to power. कितना लिया था?
10 to the power 10.
Let me check once again. Okay. So concrete we have used. Okay. So it was 2.5 10 raised to power 10. Okay. And the frame sections which we have used, the first frame section we have used, it was of concrete. This is 0.5 by 0.2. And the second frame section which we have used, it was concrete 0.5 by 0.4. Okay. So this looks good. Okay. So can someone please do the calculations? So this E value is kitna tha? 2.5 into 10 raised to power 10, isn't it? कहाँ गया? इसमें आ नहीं रहा है. Theta 2, somebody please tell me the numerical value.
Minus 3.86 into 10 to the power minus 7.
Let me note down. Huh?
Yes, sir.
So T2, how much is that? Minus?
Sir, theta 1.
Theta 1 will be 0, no? Theta 2.
हाँ sir, theta 2.
Theta 2 will be minus how much?
3.8649 into 10 to the power minus 7.
Minus 7. Okay. And theta 3, someone please.
3.139
Hmm?
into 10 to the power minus 7.
Into minus 7. Okay. So let me check these values in the SAP. Okay. So if you want to see the results, so here this is a deformed shape. Okay. Here you can have the forces and reactions. So here, if you want to see the reactions, so you can see this is the vertical, or this is downward reaction, this is vertical reaction, and this is also vertical reaction. And if you want to see the shear force and bending moment diagram, you can see the shear force diagram. So this is the shear force diagram. Okay. And this is your bending moment diagram. Okay. So coming to the main part, that is exporting the files. So we can say file export, print output tables. So in the print output table, I'm going to print the displacement as well as the reactions as well as the frame forces, and this I'm going to print into a file in the location that is c/sap/experiment1.txt, and I'm saying okay. Okay. So let me open the file now. So this is C drive, there is a SAP, and the file name was expt1.txt, or you can use this one. Okay. So you see this is the value over here. So the first is this one. So this is 3.89 10 to the power minus 4. How much value you have obtained? So something like 3.84. Okay. So this value looks good. There is some issue with this one, T3. So can someone check this, please? Check this calculations, please. T3 or the rotation at the third point.
Sir, it's coming 3.9 into 10 to the power minus 7 itself.
Which one? First one or second one? Rotation at first point
The
or
second one is
second point?
6.276 into 10 to the power minus 7.
ये वाला ना?
Yes, sir. Second wala 6.278.
6. 6.2 76.
6.276
हाँ, 6.276 10 to the power
minus 7.
Minus 7.
minus 7. ठीक है? So you see only the sign difference is there. So here the nomenclature which is used clockwise or anti-clockwise, the value of negative and positive they will be changed. Okay. So but if you see the magnitude, the SAP is giving you 3.89. Here you are getting 3.86, and here if you see you are getting 6.3. So you are getting 6.27. We are getting values into the power minus 4. ठीक है, और यहाँ पे आ रहा है अपना a to the power minus 7. ओके, सो दिस मे बी ड्यू टू 10 to the power 3. शायद e की वैल्यू में गड़बड़ किया तुम लोगों ने, तो that is quite possible. But as far as the values are concerned, they are very much in the limit, and this solution is very much correct. So there is no issue in that. And if you want, you can have the forces and moments at different location. So for example, this is your joint number 1. So joint number 1 is basically your fixed support. So in the fixed support, so this is dx, dy and dz. So there is a vertical reaction, or rather I should say downward reaction, because it is negative. So downward reaction of 2272.39 newtons. Okay, and there is a rotation which is there, that is 4478.34. This is Newton meter. So this is the reaction at joint number 1. Then this is the reaction at joint number 2. So this is the vertical reaction. So this is a roller support. So you will find rest of the things are 0. The joint number 3 is also a roller support. So you will find this is also 0, or the rest of the things are 0, but vertical direction is reaction is there. If you go down, you will find this is the shear force variation, and this is the moment variation in member 1. So at every the member is basically divided into 5 parts, and after every one interval, you will find the values of shear force is calculated, and here you will find the bending moment is also calculated over here. Okay, and similarly you will find the variation of shear force and bending moment. So shear force is over here. This is for member number 2, and this is the bending moment variation for member number 2. Okay, so our answers are correct. So please check your calculations once again. There is a
E value was wrong, sir. It was a 10 to the power 5, not 10.
Anyway, so there is a difference of just 3, 10 to the power 3. तो उसमें न्यूटन किलो न्यूटन का कुछ ना कुछ गड़बड़ हुआ है. Okay, so you just do it very carefully, but as far as values are concerned, values are correct. Okay, so this is 3.86, so this is 3.89, so that's okay. The next one is 6.3, this is 6.27. okay, only thing is that there is a sign change. Okay, that is only due to the assumption, because SAP is using some different assumption and you are using some different assumptions. Okay, so that is the reason why the signs are changed, but as far as values are concerned, values are perfectly correct. Okay, I hope this is clear to you. Any questions? Yes, boys, girls, any questions, please? So सब लोगों ने सॉफ्टवेयर इंस्टॉल किया है क्या? नहीं किया है, अभी डाउनलोड करो और ये वाला प्रॉब्लम अभी सॉल्व करो, और सॉल्व करके मुझे स्क्रीनशॉट भेजो गूगल क्लासरूम पे. देन आई विल गिव यू अनदर प्रॉब्लम फॉर सॉल्विंग. पहले ये वाला प्रॉब्लम सब लोग सैप पे सॉल्व करेंगे और मुझे स्क्रीनशॉट भेजेंगे. ओके, प्लीज डू इट एवरीबॉडी. Anybody is having any questions?
Sir,
Yes, please.
can you send this recording on the classroom?
Okay. Let me stop the recording first.